In this video, I'm going to do 2 multiple choice problems and then 2 free response problems on limits and continuity. So I hope you guys enjoyed this video. Okay, in this problem, let's take a look at this. This is a piecewise defined function. I know that's a line. I know that's a line. Lines are always continuous, but they broke up those lines. They broke up those lines at 3. Let's see what happens when you put 3 there. You get 5. Let's see what happens when you put 3 there. You get 5. There's also an equal sign. So guess what, guys? The limit exists. It's continuous as well. I know we haven't discussed derivatives yet, but some of you might know the power rule. The derivative of this guy here is just 1, and the derivative of this guy here is just 4. These two don't match, therefore it's not differentiable. If you guys don't understand choice 3 yet, that's okay. It's not your fault. I didn't teach you guys derivatives yet. But I hope everybody gets number 1 and number 2. And just remember that if something is continuous, then if a function is continuous, then the limit does exist. Okay, we got time for one more? Sure. Does the limit exist? For which of the following does the limit as x approaches 4 of f of x exist? So let's go to 4, 4, 4. Well, of course the limit exists for number 1. This is not continuous, but the limit exists. From the left, I go there. From the right, I go there. I go to the same point, so it exists. From the left, I go to that point. From the right, I go to that point. The limit exists. It's not continuous in choice 1 or 2, but the limit exists. Choice 3, no way. From the left, I go to that dark point. From the right, I go to the hole. It jumps. So our answer is only choice 1 and 2. I hope that makes sense. Let's see what the next problem is. Part of a free response problem in 2011 on the AP Calculus was this here. It says, let f be a function defined by f of x, which is a piecewise defined function. Show that f is continuous at x equals 0. To show that a function is continuous, you have to take the limit as x approaches 0 from the left first. Let's see what that is. That's this guy here. When we put 0 in there, I hope you guys remember that 1 minus 2 times sine 0 from the left is just 1. The limit as x, because sine 0 is 0. The limit as x approaches 0 from the right of f of x, we have to use the other guy. Well, e to the 0 power is also 1. Well, you're not done there. Yes, the limit as x approaches 0 is now 1 because these two match. We also need to check what happens at 0. At 0, we choose this guy right here. And we get 1. Okay, now that the limit as x approaches 0 of f of x exists and is equal to 1, and f of 0 is equal to the limit as x approaches 0, therefore it's continuous. I hope that was good. Let's try one more. Let f be the function defined by this. Is f continuous at x equals 3? Explain why or why not. Once again, we follow the same format as we did in the last video. We're going to figure out what the limit as x approaches 3 from the left is of this function. And that means I'm going to use him. So that's going to be the square root of 4, which is 2. We're going to take the limit as x approaches 3 from the right. And that's going to be 5 minus 3, which is 2. The limit as x approaches 3 is now equal to 2. And we know that f of 3 is also equal to 2. Therefore, the limit as x approaches 3 is equal to the f of 3, and f of x is continuous. So That's what you need to show for continuity. And that's all for this video. I hope that was helpful.